Right. So as we said earlier, that as you were challenging me earlier, maybe, about creating tables that that were gathering information, that we were inserting data into tables based on other tables, right? We were joining a couple of tables, retrieving some records from there, and populating a brand new table, right? And I pointed out the fact that perhaps that's not a good idea, right? That we would be inadvertently introducing redundancy into our database, right? If the data is already stored across multiple tables, and we certainly can go and retrieve it any which way we want it, we would only perhaps create another table only for convenience, right? For somebody's convenience, right? Because it might be convenient to consume the data everywhere in one particular table, right? Just like maybe it was convenient to have one spreadsheet with all the fields, right? And then we realized how foolish that was, and we started pointing out that perhaps we should normalize this, right? And to split it into multiple records, into multiple tables. Yes. But nevertheless, the need or the use case is a valid use case. That oftentimes we want to be able to consume the data in a particular way that is convenient, especially for folks that might not use the database or might not be responsible for maintaining the database. They just want to be users or consumers of the data, right? For that, we have the capabilities of creating a view. A view is somewhat of a virtual table, right? That you can treat it as if it were a table, but it's not a real table, right? It's a query that we can name, that we can give a name to, so that we can then reuse it as if it were an actual table, right? And what allows you to do is to provide denormalized access to the database, right, without actually denormalizing the database, right? Just because consuming the data might be convenient one way doesn't mean that you have to design it, in such a way that might introduce redundancy, right? Redundancy is never good, right, regardless on how convenient it might be to do otherwise. Okay, so views allows us to deal with these kinds of things, where the way it works is that you provide a select statement that perhaps you found to be very convenient, right? That might be very convenient for certain audiences, where they might, maybe the registrar's office or the dean's office, it might find it very inconvenient to go and fetch information from the student on this table, then their major in some other department table, and then all the courses over there and all the sections over there, right? It might be very inconvenient to have these long, complicated joins and select statements. So what we typically do is that, okay, well, here's your select statement. What we can do is just give it a name. Right? We can give it a name, and then you can treat it as if it were one big spreadsheet. Okay, and it'll be convenient for you to consume it. So there it is. So you can have a select statement that it can be as complex as you want it. And so this is what happens, is that the select statement is the execution is deferred. This doesn't actually execute not until you use the view, right, in an actual query. Then once you use it in the query as if it were a table, then the select statement executes. It runs as if it were that one particular time, right? So this gives you the convenience of accessing a denormalized schema without actually denormalizing it, right? One of the challenges here is that this select statement always executes, which is good and bad. Well, it's good because whenever you access a table, you're always looking at the latest values of the actual records from the actual tables. That's a good thing. The bad thing is that it executes every time. They're expensive, right? These are not real tables, right? If this is a three-way join, you are actually joining these tables every single time you treat this a table. If this were a real table, there would not be any join, right? They would actually physically live in that actual table. Yes? You would not incur in the the expense of having to join the tables if it were a real table. Right? So yeah, it has pros and cons. So here's an example of a view. Right? Create view, current product list. Here we're mixing and matching some spaces in there, so you could be fairly verbose. It's not a real table, right? So we can give it a name whatever we want it. Here and it's joining. Actually, it's not joining two things. It's retrieving two fields from a product. So yeah, so this might be a very convenient query that I use every day to identify from the thousands of products that I have. I only want to know a subset of the products that have not yet been discontinued, right? And so I want to keep track of my 100 products out of the thousands that have not been discontinued. So instead of having to run the select statement every single time, instead I name it, give it a name, and then I can treat it as if we're an actual table, right? I can select star from current product list, and then notice that it's in the from clause. Treat it as if it were an actual table, but it's not, right? It's a virtual table. You can have as fairly complex queries where you can have a select statement, and inside of a select statement you can have perhaps another select statement embedded inside, which is pretty cool. You can have these are generally referred to as a subquery, right? Anywhere where you have a select statement, you can replace it with a view. Just like this select statement is being replaced by this named view, this subquery could also be replaced by a view, right? We could give it a name, and so this could be a view built on top of another view, which is pretty cool, right? You can have views within views within views, as complex as you like. So here's just an example of a query that has that named query, category sales for 1997, that is using a select statement that in itself the from clause is using another view, right? So there's a view built on top of another view, right, and then used as a regular table, right? Now we've actually been using views, the idea of views, all along. Right, from day one. Right, from day one, we already have been using the following syntax, where we have a left-hand side equal a right-hand side. Right. So this was a somewhat of an intro to views. We already know what that is, right? This is identical to being able to write something like this. Right, Q65 equals whatever the select statement can be formally written as create the view Q65 as and then the select statement. So we've already been using views all along, right? And then reusing them as input to other more complex queries. Okay. Right. So Q's in here. I'm sorry. The views Q65 is being used as a table. And it's the equivalent, as I mentioned earlier, as an embedded query, right? That we can replace it there with an actual view. So if you use the actual select statement as opposed to the view, oftentimes we refer to that as an inline view, right? Something that could have been replaced by a named view. And this is the way we implement what we refer to really early at the beginning of the semester. We call them the external schemas, right? Schemas that are one higher level of abstraction conceptually that you might provide for different audiences that might want to consume this data in a denormalized way, right? And views and materialized views, as we'll talk about a little later, are a very convenient way to implement these external schemas, right? Schemas that are not the physical schema that we store the data, right? Is a schema. It's a virtual schema that we can provide as a facade for folks that use the database, right? So here's an example on what this external schemas might look like. Depending if you're the registrar's office or the dean's office, it might be convenient if there were a table that would collate the data about students and the courses that they failed, the courses that they passed, right? and perhaps I'd like to know about all the information about students and courses. You know which students are enrolled in which courses and who's teaching it and what grade did they get, right? Each one of these is perhaps several joins across multiple tables that I need to gather, group by, order, right? Retrieve all these fields, have lots of complex select statements and queries and predicates that I might want to feed in there. So I would have never actually created a table called student info, right? If we would have found this and actually implemented it, because it might have been in the requirements, right? It could have been in the requirement, the original requirements. And as we implemented the requirements and we actually had this table, we probably would have realized that there was redundancy, right? That it broke, first normal form or second normal form or third normal form, right? And we would have realized that this is not a good idea. We probably would have broken it up into a student, right, and a course, and a section, and an enrollment. Yes, like we did. So we no longer had this student info table because we realized it was a bad idea. Okay? But nevertheless, the requirement still stands. They want to be able to consume it, right? So a view would be a perfect solution for this, right? I first normalized. Once I normalized, I then come back and provide a denormalized view that can gather all this information into one convenient pseudo table. So yeah, for instance, the student courses table is joining three different tables. The enrollment table, the section table, the course table. So it's gathering information from multiple sources, right? And based on this criteria, is then populating the view every time you query it, right? So this is a convenient. So this would not be an actual table that you would actually build. Instead, is conveniently implemented as a view. Now, once you start using a view, very much like a table, you might get a little. You might get a little ahead of yourself and actually treat it as if it were an actual table, right? Because you've been selecting from it and you've joined it with others, right? You've been retrieving data, and you kind of forget that it's not a real table, right? And there's certain things that you can't do with a view, right? If we understand what they actually are, right? They're not any physical table, right? Instead, there's something that they're computed on the fly whenever we query something, right? So one of the things that we can't do is update a view. Update a view. What would that mean? Right? Well, updating a table, what does updating a table, what does that entail? It means that I need to identify the original record based on some criteria, and then I need to change some field in that record, right? That's what an updating a table means. But if we consider updating a view, which is not a real table, what would that even mean? Because a view might be, has some fields that come from one table, some fields come from another table, and some other fields might come from a third table, right? So the fields in a view are actually an aggregate, right? A composition of multiple fields from multiple tables. So if I identify a particular record in a view and I say that I want to change this particular field in that record, what would that mean? That means that somehow that field needs to find its way back to the original record in the original table and fix and change it in the original table, right? In the original record, right? And same thing, if I modify this other field over there, that means that it has to somehow trickle to the original field, the original record from the original table, right? So it's not trivial. If the record in the view unambiguously maps to individual records in the original tables, perhaps we could write something that would allow us to, changes in the view trickle to the changes in the original tables, right? But what if we have a group by, say, right? That the view does a group by. Now, the record, right, in the view, right, a particular field in that record in that view, actually represents multiple records in some other table, right? So updating that would mean, what would that mean, right? What would it mean to the original records that were aggregated to calculate that one field? It would make no sense, okay? What about being able to perhaps remove a record? Right. So never mind update. What about removing a record? What would that be? What would that mean? Okay, because this record in the view was calculated based on multiple records from multiple tables. Does that mean that if I remove a record in the view, I remove the original records in the table where they came from? Probably not. Okay, perhaps the record was built from a join, right? From a join of two different tables. If I remove the record, what does it mean? Does it mean that I remove the relationship between the two? That the foreign key that was used to do the join should now be null? They're no longer related somehow? Does it mean that I remove one of the records but not the other? Right. So notice that the real action that should happen is not clear what should happen. So multiple. When you have views where you have multiple tables, certainly we would not allow any updates. So let's look at what this might entail. So for instance, here we have a view called student major. It's joining two different tables, right? From the student table and the department table. It's joining them. And now we have some fields from the student table and some fields from the department table, right? So some fields come from one and some the other fields. So what would it mean, for instance, that I remove this record over here? What would that mean? Or that I update it, right? So I want to be able to say instead of art, now you're in the physics department. What does that mean? What would it mean to the original records in the original tables? So for instance, if I delete Joe and Art, how should that be interpreted? Does it mean that I'm going to remove the record for Joe and I remove the record for Art? Probably not. That would make absolutely no sense, right? Or something that might make sense would be that perhaps Joe's foreign key to the department that they are enrolled in, right? Perhaps that should now be null, right? That they're no longer enrolled in that particular department. Or that maybe they're enrolled in some other department, right, but not in art. Maybe that's what it means. So there is no one real good answer on what is it that we might want to do. Or what about if I insert another record, right? Joe is now enrolled in art, but now I enroll Joe in drama. What would the interpretation be in that case? Does it mean that I remove this record and I now insert a new record? Does it mean that I update something that is already there? What does it mean, right? Or do I change this foreign key to point from one department to the next? So there's nothing that we could tell the database to do one thing versus another. Or is there? Well, not with views, right? Not with views. Instead, what we'll introduce next is being able to programmatically tell the database what is it that we actually want to do, right? And that's where store procedures comes in. Right? Store procedures can listen for inserts, listen for updates, listens for deletes, right? And we can encode certain logic and say, well, this is exactly what I want to happen, right? For instance, if you remove this record from this view, this is what I want to happen. I want to make this null. I want to do an insert over there. I want to do a delete over there. And manipulate the data as we like. Okay?